Coffelt. I'm a PhD student from the University of Bremen in Germany. In this work, we present novel solutions for simulating and eliminating marine snow in video. Marine snow is organic debris that falls through the water column, appearing to look like snow falling through the sky. It's good for aquatic ecosystems. It's bad for computer vision tasks and marine robots. Our approach for eliminating marine snow in video begins by extending a UNet architecture previously shown to successfully remove synthetic marine snow from otherwise real underwater images. We modified that network to accept video sequences rather than single images as inputs. An example of the only previously available marine snow dataset is shown to the right. That dataset consists of real underwater images with synthetic elliptical snow overlaid on top. This dataset seems very well suited for stationary cameras and well-lit underwater scenes, but it didn't seem to extend too well to scenes we were encountering in recent field trials. So we set about creating our own synthetic underwater dataset to train our UNet architecture. We begin in Blender by creating a scene like the one shown below. We then use what are called geometry nodes to add the marine snow. This allows full control of the distribution, size, shape, and material properties of the marine snow. Examples of the scenes we created are shown here. At the top, you see snowless videos. In the middle, you see the snow masks. And at the bottom, you see the videos combined. We created 4 scenes, one with an underwater pipeline, another with a shipwreck, one with a relatively stationary camera tracking a moving AUV, and a final one involving an underwater gas infrastructure system. Results of the various models are shown here. On the right, you see the output of the median filter, which is a classical traditional approach. In the middle, you see the difference between the input and output images. In general, green is good. It's correctly removed marine snow, and red is typically bad. It's pixels that were incorrectly adjusted. So notice that the median filter removes a lot of marine snow, but it also blurs the entire image. The previous approach, using the MSRB dataset, preserves a lot of detail, but doesn't seem to remove very much marine snow. And our solution, based on our new dataset and extended video-based UNet, seems to remove much more marine snow while still preserving most of the detail in the original image. A comparison of the 3 approaches are shown here. Again, on the left is the median filter, removing a lot of marine snow but blurring the entire image. In the middle is the MSRB solution, removing some marine snow while preserving almost all detail. And at the far right is our solution, which seems to remove quite a bit more marine snow without compromising too much detail. So in conclusion, this work shows a new approach for generating synthetic training data for marine snow simulation, isolation, and removal. It extends a deep neural network for eliminating marine snow from both images and video. And we created a publicly available benchmarking dataset for marine snow simulation, isolation, and removal, especially targeted at deep sea robotics. This is the source paper for the marine snow removal benchmarking dataset. This is the link to their online repository, and this is a link to our online repository. I would like to thank my co-authors and the EU for funding this research. Thank you.